In previous class, we studied the root mean square value of alternating current, which we recall as root mean square value of an alternating current is that value of steady current which would generate the same amount of heat in a given resistance in given time, as is done by the alternating current when passed through the same resistance for the same time. Now, today it is root mean square value of alternating EMF. Similar to alternating current, the root mean square value of alternating current is defined as that value of steady voltage. Here it is steady voltage which would generate the same amount of heat in a given resistance in a given time, as it is done by the alternating EMF when applied to the same resistance for the same time. The root mean square value, it is also called as effective value or virtual value of EMF, same that as root mean square value was called as effective value of alternating current or virtual value of alternating current. It is represented, this root mean square value of EMF is represented by E is equal to E0 sine omega t. Small amount of heat produced when this alternating current, when this alternating EMF is applied to resistance R for a small amount of time, dt is dH is equal to E square by R dt, giving the value of E square. This will be equal to E naught sine omega t square by R dt, that is dH is equal to E0 square by R sine square omega t dt. For one complete cycle, when time is from 0 to t, total amount of heat produced in resistance R, total resistance will be given by integrating this relation dH. Total amount heat will be H equal to integral of 0 E0 square by R sine square omega t dt between the limits 0 to t. E0 by R, these being constants, E0 by E0 square by R, integral will be to sine square omega t dt, which is equal to 1 minus cos twice omega t by 2. Then integrating this cos twice omega dt, integral of cos twice omega 2 omega dt between limit 0 to t is equal to 0. Here only remains integral of 1. That will be, we will get h equal to E0 square by 2r. 2 constant comes out of the integral. T, limits of t between 0 to t. Here it is t. Now it is value of heat produced H is equal to E0 square by 2r between the limits, that is t minus 0, which will ultimately be equal to E0 square RT by 2r. If this is the heat produced in EMF, alternating EMF, heat produced in alternating EMF, H will be equal to E naught square by T, E0 square T by 2r. If EV is the root mean square value of alternating EMF, then the amount of heat produced in the same resistance in the time t is H is equal to EV represents the root mean square value of heat produced, EV square by RT, that is EV square will be equal to E0 by 2, which will give the value EV equal to E0 square cancels E0 by under root 2. Its value becomes, on calculating by rationalizing, under root 2 by under root 2 becomes equal to 0.707 E0. That is, the root mean square value of alternating EMF is 0.707 times the peak value of alternating EMF. This completes root mean square value of EMF.